Hello everyone and welcome. Now in this lesson we are going to continue our series on carbon and its compound, and in this particular video you are going to learn about the trioxocarbonate 4 acids, trioxocarbonate 4 salts, their certain properties and their method of preparation. To begin with, we are going to start by talking about trioxocarbonate 4 acid. You remember that trioxocarbonate 4 acid is a weak acid, and that will mean any acid that partially dissociates into ions. That means its molecules partially split into ions when they go into solutions. Now, the structure of the acid is shown here, and here you can find that you have a CO3 2- radical, that is a trioxocarbonate 4 radical ion bonded to 2 hydrogen atoms. This makes this acid a dibasic acid, an acid that has 2 replaceable hydrogen ions. Now, since it is dibasic, this will cause the acid to be able to form 2 types of salts. Monobasic acids form 1 type of salt, tribasic acid can form up to 3 types of salts, but the dibasic acid, as in the case of trioxocarbonate 4 acid, will be able to form 2 types of salts when the hydrogen ion, these are replaced by a metallic or ammonium ion, for instance like sodium. First is an acid salt when only one of the hydrogen ion is replaced. And when an acid salt is formed, we are going to have something like this. If we are using the metallic ion to be sodium ion, you are going to have sodium hydrogen trioxocarbonate 4, an acid salt. And secondly, this can also form a normal salt when all the hydrogen ion is replaced by a metal. So you have another sodium replacing that hydrogen, and you are going to have sodium trioxocarbonate 4, a normal salt. A normal salt. Now, how is this acid, trioxocarbonate 4 acid, prepared in the laboratory? Let's go and find. Trioxocarbonate 4 acid can be prepared in the lab, but actually this method of preparation actually happens in the atmosphere, in our ecosystem. Trioxocarbonate 4 acid is formed when carbon 4 oxide dissolves in water. Now remember that carbon 4 oxide is a constituent of air, and in the sea and water bodies you have that the carbon 4 oxide that is in air can dissolve in water, that has the sea body, to form trioxocarbonate 4. This is what you have in the lab: water reacting with carbon 4 oxide to produce trioxocarbonate 4 acid. Now remember that it's an acid, and like all acid, when they go into solution they dissociate into ions. But like all dibasic acid, the dissociation of this particular acid is usually in step. It first of all dissociates to form an hydrogen ion and an hydrogen trioxocarbonate 4 ion. Now the dissociation does not stop there, because here you are going to have a negative radical that still has some somewhat acidic property because of the presence of this hydrogen ion in that radical. So this particular radical you are seeing here, hydrogen trioxocarbonate 4, can further undergo dissociation to produce another hydrogen ion and a trioxocarbonate 4 ion. At this point, we can say the dissociation of this acid is complete. About the normal salts that are formed from trioxocarbonate 4 acid. Normal salts that are formed from trioxocarbonate 4 acid are called trioxocarbonate 4 salts. Trioxocarbonate 4 salts are salts of trioxocarbonate 4 acid. Now there are 2 types depending on its solubility. There are soluble trioxocarbonate 4 and insoluble trioxocarbonate 4. Now it is noteworthy, please take note that all trioxocarbonate 4 salts are insoluble in water. What that means is that when you take all the trioxocarbonate 4 salts you have and dissolve them in water, they are not going to dissolve. except for the trioxocarbonate 4 of all the alkali metals. Do you remember what alkali metals are? Yes. Do you remember lithium, sodium, and potassium? And I bet you still remember what these metals have in common. Now, the soluble trioxocarbonate 4 are, like I said, the trioxocarbonate 4 of alkali metals. You have sodium trioxocarbonate 4, you have potassium trioxocarbonate 4, and also ammonium trioxocarbonate 4. Now, you can also include to this list lithium trioxocarbonate 4 and all the other metals in group 1, which is your alkali metal. While the insoluble trioxocarbonate 4 are all the other trioxocarbonate 4. Think of any other trioxocarbonate 4. For instance, calcium trioxocarbonate 4, magnesium trioxocarbonate 4, and copper 2 trioxocarbonate 4. All these other trioxocarbonate 4 are insoluble. Now, the preparation of trioxocarbonate 4 salt is actually dependent on its solubility. That means soluble trioxocarbonate 4 are prepared in a certain way that is different from insoluble trioxocarbonate 4. Now let's discuss preparation of the soluble trioxocarbonate 4 salts. Firstly, soluble trioxocarbonate 4 salts are prepared by passing carbon 4 oxide through a corresponding alkali. I'm sure you remember what alkalis are. Alkalis are actually soluble hydroxides of metals. Soluble hydroxides of what? Of metals. Now, when carbon 4 oxide is passed through an alkali like sodium hydroxide, you are going to have that a trioxocarbonate 4 salt will be produced along with water. So here we are going to have carbon 4 oxide react with sodium hydroxide, will give us sodium trioxocarbonate 4 and water. Now we can do that. The same thing will also happen when we pass carbon 4 oxide through an hydroxide like potassium hydroxide, an alkali. And the other method of preparing this soluble trioxocarbonate 4 is by decomposing an hydrogen trioxocarbonate 4 salts. Hydrogen trioxocarbonate 4 salts, when they are heated, they tend to decompose to form your trioxocarbonate 4 salt. So you can have this salt, sodium hydrogen trioxocarbonate 4, when subjected to heat, will decompose to produce sodium trioxocarbonate 4, water, and carbon 4 oxide will be given off as gas. So these are the two methods of preparing the soluble trioxocarbonate 4. How about the insoluble trioxocarbonate 4? How about the insoluble trioxocarbonate 4? The insoluble trioxocarbonate 4 now, for the insoluble trioxocarbonate 4, all the insoluble salts. Now, for insoluble trioxocarbonate 4, like all insoluble salts, we use one unique method of preparing them, and that method is known as the precipitation method. And remember, this precipitation method can also be called your double decomposition method. What actually happens in this method? In this method, two soluble salts, one containing a trioxocarbonate 4 radical, that is the CO3 radical, and must be soluble. In this case, we usually use sodium trioxocarbonate 4 or a sodium hydrogen trioxocarbonate 4 radical. And another salt containing any other radical, like your triazonitrate 4 radical, or your tetraoxosulfate 6 radical, or even your chloride ion. Both of these salts, both soluble, are reacted together. Now, when both of them react, what you are going to have is that they will both decompose, which is the reason why it is called double decomposition, to form a soluble salt and an insoluble salt, like you can have here. So you have this salt containing a CO3 radical, then another salt containing the other radical of your choice, as containing any other radical. Both of them will decompose to form two salts, one of them being soluble, in this case sodium chloride, and another which is insoluble, which we usually call the precipitate, after which this method is named. I told you can either use your sodium trioxocarbonate 4 or your sodium hydrogen trioxocarbonate 4, like you can see in this example below. Now, there is something of importance here, and that is that if the trioxocarbonate 4 we want to produce is the trioxocarbonate 4 of a less electronegative element like magnesium. Now, instead of using this salt, what we usually use is preferably a sodium hydrogen trioxocarbonate 4. Now, these are the method of preparing your insoluble trioxocarbonate 4 salt. Now, let's move over to talk about their properties. There are several properties of trioxocarbonate 4 salt, and these properties are outlined as the first one being solubility. All trioxocarbonate 4 salts are insoluble except for the trioxocarbonate 4 of sodium, which is your Na2CO3, potassium, K2CO3, and ammonium trioxocarbonate 4. All these type of trioxocarbonate 4 salts are actually soluble. All other types are insoluble, as you have seen. Now, another property of trioxocarbonate 4 salts is their decomposition. Now, all trioxocarbonate 4 salts, when they are heated, have the ability of decomposing to form several other substances. But there's an exception. The trioxocarbonate 4 of sodium, potassium, and barium, it was found out that when these salts were heated, they remain the same. That means they do not decompose. They do not what? Decompose. And to show this, we have a chemical equation here. This is calcium trioxocarbonate 4. When it is subjected to heat, we produce calcium oxide, a basic oxide, and carbon 4 oxide. Another example would be when ammonium trioxocarbonate 4 is heated, it decomposes to produce ammonia, water, and carbon 4 oxide. Now, there are several other properties, and these properties include their reaction with acid. When trioxocarbonate 4 salts react with acid, they react to form salts. In this case, sodium trioxocarbonate 4 reacting with HCl will give you sodium chloride, water, and carbon 4 oxide, which is given off or liberated as a gas. Another very unique property, which is a property of most salts, is hydrolysis. That is a salt reaction with water. When the trioxocarbonate 4 salts dissolve in water, they get hydrolyzed to produce either an acidic or basic solution. Now, the one it produces is actually dependent on the metal of the trioxocarbonate 4. So you have, for instance, sodium trioxocarbonate 4 dissolved in water will produce two types of substances, sodium hydroxide and H2CO3. Now, these when dissolved in water, they hydrolyze to give either an acidic or a basic solution. In the case of this particular one, what you are going to have is that you are going to have a basic solution due to the presence of a strong base, which is sodium hydroxide. Now, let's talk about the uses of trioxocarbonate 4 salt. There are several uses of trioxocarbonate 4 salts. And to begin with, we are going to talk about calcium trioxocarbonate 4, which is used in the extraction of iron from its ore and in the manufacture of cement. I'm sure you know about cement and how it is manufactured. Another salt is your potassium trioxocarbonate 4, which is used in the manufacture of glass. Sodium trioxocarbonate 4, which is used in controlling the pH of water, like your swimming pool, the water in your swimming pool. Now, it can also be used as a food additive that is added to foods to give them certain properties, and it can also be used to soften hard water that are hard and find it difficult to lather with soap. This can be softened and changed into soft water by the addition of sodium trioxocarbonate 4. And also, it can be used in the manufacture of glass, just like your potassium trioxocarbonate 4. Now, let's now discuss the acid salts of trioxocarbonate 4 acid, known as hydrogen trioxocarbonate 4 salts. Now, hydrogen trioxocarbonate 4 salts are salts that are formed when only one of the hydrogen ion in your trioxocarbonate 4 acid is replaced. So this is the structure of your trioxocarbonate 4 acid. Imagine now that one of its hydrogen is replaced by a metal or an ammonium ion. Now we are going to have this. Let's assume the metal is sodium metal. When it replaces it, what it is going to form is your sodium hydrogen trioxocarbonate 4 salt. Now, how is this salt prepared in the lab? It is prepared by reacting the acid with a substance that contains a metal, like sodium hydroxide. So we have something like this. Preparation of hydrogen trioxocarbonate 4. It is prepared by reacting the acid with a substance containing a metal like sodium hydroxide. When you have this, what you are going to have is that the metal will replace the hydrogen ion in this trioxocarbonate 4. Now, because it's an acid source, you should know that it is not going to completely replace all of them. It will replace just one. And for this to occur, this reagent here, sodium hydroxide, has to be in a limited supply in relation to the amount of the acid. That means this one will be less in amount than this, which is your acid. Now, when both of them react, you are going to have something like this: sodium hydrogen trioxocarbonate 4. The sodium atom is only successfully replaces just one hydrogen ion. We can also try that for another metal, for another substance, when it reacts with calcium hydroxide, and you are going to have that the calcium hydroxide, the calcium atom will only be able to replace just one hydrogen ion to give us calcium hydrogen trioxocarbonate 4 and water. And you also remember that this type of reaction in chemistry is your neutralization reaction. Now let's quickly discuss the properties of these acid salts. Firstly, their physical state. Firstly, their physical properties. Now, one will assume that they will all be solid at room temperature, but we find out that only the hydrogen trioxocarbonate 4 of sodium, potassium, and ammonium exist as solid at room temperature. Only sodium hydrogen trioxocarbonate 4, potassium hydrogen trioxocarbonate 4, and ammonium hydrogen trioxocarbonate 4 exist as solids in their room temperature. All the others do not exist as solids. Good. Another property of hydrogen trioxocarbonate 4 is their decomposition. Now, under heat, they decompose to form three substances. They decompose to liberate carbon 4 oxide as a gas, water, and the corresponding trioxocarbonate 4 of the metal. To accompany that, we have a chemical reaction here. Sodium hydrogen trioxocarbonate 4, when heated, will decompose to give us sodium trioxocarbonate 4, that is the corresponding trioxocarbonate 4, water, and carbon 4 oxide will be given off as gas. Now, with acids, another property of trioxocarbonate 4 is their reaction with acid. When they react with acid, they liberate carbon 4 oxide while also producing water and a salt. A very unique type of hydrogen trioxocarbonate 4 known as sodium hydrogen trioxocarbonate 4. This particular substance here is very useful and used in the environment, in our houses, for different purposes. It is usually called baking soda. Now, how is this trioxocarbonate 4 prepared? Laboratory preparation of sodium hydrogen trioxocarbonate 4. Now, sodium hydrogen trioxocarbonate 4 can be prepared in the lab on a small scale, but as well it can also be prepared in the industry. We are going to come to that. But before we see that, let's see how it is prepared in the lab. In the lab, it is prepared by passing excess carbon 4 oxide through sodium hydroxide. an alkali. Now, when you pass excess carbon dioxide through sodium hydroxide, it's actually in two steps. First of all, when the carbon dioxide passes through the sodium hydroxide, you are going to have two products, which are sodium triosocarbonate 4 and H2O, which is water. Now, this is your first time of passing it. Now, after passing it the first time, when you now pass the carbon dioxide through the products in excess, these are the two products in this case, sodium triosocarbonate 4 and water, you now pass through excess carbon dioxide. This is what you are going to have. The products here again, plus the excess carbon dioxide in excess now will give us sodium hydrogen triosocarbonate 4. That is 2 moles of sodium hydrogen triosocarbonate 4. This is how it is prepared in the lab, by simply passing excess carbon dioxide through sodium hydroxide. Now, industrially, it is prepared by a process known as the solvent process. Now, let's go find out how that is done in this video you are about. Preparation of sodium hydroxide through the
Hello. Our today's topic is manufacture of sodium carbonate by Solvay's process. So let's get started. Solvay's process is used to manufacture sodium carbonate because we use sodium carbonate for many purposes. This sodium carbonate is produced in industries. Now, what are industries? Industries are the places where we use raw materials and form new products. The principle of Solvay's process is to manufacture sodium carbonate at low temperature. The raw materials that we need to start our industry are sodium chloride NaCl or brine, limestone CaCO3, and ammonia NH3. We shall provide all these things to industry to manufacture the required product. But we don't need to give these things all the time. Once we provide our raw materials, we will set up our industry in such a way that after the manufacture of product, we will again have our raw materials. This is the flow chart of our industry. We will discuss each step accordingly. There are 4 chambers in this industry. First is ammoniating tower. Second is carbonating tower. Third is lime kiln. Fourth is ammonia recovery tower. We will provide ammonia gas, sodium chloride, and water to ammoniating tower. The mixture of these substances is called ammoniacal brine. After the preparation of ammoniacal brine, the ammoniacal brine is passed into carbonating tower. Carbon dioxide passed through it, and these reactions takes place. Firstly, carbon dioxide, ammonia, and water gives NH4 hours CO3. This product is intermediate and speedily give its reaction with NaCl brine and form sodium bicarbonate and ammonium chloride. The temperature is lowered to 15 degrees and sodium bicarbonate is obtained. After obtaining, we will filter the product for the less chances of useless impurities. After the filtration, we take sodium bicarbonate and heat it, because we are manufacturing sodium carbonate. After heating it, we will obtain sodium carbonate, carbon dioxide, and water. This process is called calcination. Thus we have manufactured our required product, which is sodium carbonate. But as we have discussed earlier, that we should set up our industry in such a way that at the end, our raw materials will again produced. Here we are also seeing CO2 and water. So now we are gonna set up industry in this way. We will introduce a new chamber in our industry. that is called lime kiln. We will provide CaCO3 in it. CaCO3 decomposes and produce calcium oxide and carbon dioxide. This carbon dioxide goes to carbonating tower. Thus our first raw material is produced. The calcium oxide reacts with water that was formed when we heated sodium bicarbonate to sodium carbonate. They both react with each other and form calcium hydroxide, which goes to our last chamber, that is ammonia recovery tower. The ammonium chloride that was formed during decomposition of sodium bicarbonate and the calcium hydroxide, which was formed in lime kiln. They both react and form ammonia, water, and calcium chloride. Ammonia is reused, while the other products goes out. Now we shall summarize the whole topic. First chamber we have ammoniating tower. We will provide sodium chloride, water, and ammonia to this chamber. This mixture is called ammonical brine. This ammonical brine is fed into carbonating tower, in which carbon dioxide is passed, which produces sodium bicarbonate and ammonium chloride. This sodium bicarbonate changes to sodium carbonate. Thus sodium carbonate is our required product. Now we will manufacture our raw materials. We introduce a new chamber which is lime kiln. Calcium carbonate heated and produce carbon dioxide which goes to carbonating tower. Here calcium chloride is also produced, which reacts with water and goes to ammonia recovery tower, at which ammonia is recovered. The ammonium chloride produced in carbonating tower goes to ammonia recovery tower. In this chamber, ammonia is recovered while the other product goes out. So that was our today's lecture. I hope you understand. If you